Okay. Now, sometimes when we're looking at our denominator, like in this example, take a look at that denominator, try and factor it. You run into troubles. You go, okay, no worries, I can't factor it, but I do know the quadratic formula. Let's try that out. We get 4 plus or minus the square root of 4 squared, negative 4 squared. Minus 4 times 10 times 1, all divided by 2. And when we look at this, we say, okay, this cannot be factored. This has no real roots because inside of our square root, we see 16 minus 40. Okay, so this denominator is what's called irreducible. It has no real roots. Oh dear. Okay, so how are we going to find the inverse Laplace transform? If we look at our sheet, we're going to see that there are a couple of cases here that also have no real roots. So, for example, if we look at numbers 9 and 10, I'm going to write those down for you. When we look at numbers 9 and 10 here, what we see is that our denominator looks like a perfect square, so that's going to be 0 or more, plus another perfect square. So what that means is these denominators also have no real roots. So that's a clue for us that we're probably going to be trying to rewrite f of s here into that kind of format. Okay. All right, so there are a couple of pieces going on in these denominators. Let's take a look. So our denominator here is s squared minus 4s plus 10. And we're going to look at how to rewrite it so that it has this kind of form of a sum of perfect squares. What we're going to start with is completing the square using these first two terms. Okay. So the idea for this is that if you saw, if we wanted to look at s minus, I'm going to write b squared. Then when we expand this out, we have s squared minus 2b plus capital B squared. Okay. 2bs, whoops, plus b squared. So any time we have a sum of our variable squared plus or minus a coefficient times s, we are kind of close to one of these formats. In fact, we'll only differ from it by a constant. Okay, so when we see this s squared minus 4s, what we're going to be doing is see how this, we see a minus 2bs in the expanded form where b was the thing that we were subtracting. Okay. So we're going to take this coefficient negative 4 and divide it by 2, and that will be our b. So we have s minus 2 squared plus something. We're going to make sure that we're actually equal to this original expression. So I'm just going to multiply this out. We have s squared minus 4s plus negative 2 squared gives us 4. We've added in 4 to our expression, so I'm going to subtract it away. And then we also had this original 10. Okay. So these first three terms bundle up to make s minus 2 squared. And the second two terms are that question mark, that constant that we didn't know. So minus 4 plus 10 gives us 6. Okay. So what we're going to do is just rewrite our expression so that it has this form of a sum of squares. Okay. So f of s here equals s plus 3 over s minus 2 squared plus 6. And let's just take a minute to match the things in our formulas, just so we can see how well things match up. Inside of this square here, we see an a and a 2. So in our expressions, a is going to be equal to 2. And notice this other part of the denominator, we have b squared, and that's equal to 6. Okay, so that's going to mean that b is going to be square root of 6 here. Okay. All right. Now, if we look at these formulas, we're going to be breaking this up much like we did in the case of having a denominator that was like s squared plus 9 or whatever it was, where we break this up into pieces that look like sine, that look like formula number 9, and formula number 10. Okay, so the most important part for doing that, the part that we don't have a lot of control over, is this numerator s minus a. So we're going to focus first here on this s. Okay, so according to the formula, we need our numerator to look like s minus a. We can do that. We can always subtract 2, but we don't want to mess with the value. So after I subtract 2, I'm then going to add 2. Okay. So this plus 2 plus 3, we can gather together, and they give us 5. And so we have the f of s here can be separated out into 2 pieces. We have s minus 2 over s minus 2 squared plus 6 plus 5 over s minus 2 squared plus 6. Okay. All right. Now the first term, when we're looking at inverse Laplace transforms, goes through pretty easily. We've already figured out that a is equal to 2 and b is supposed to be square root of 6. So we're just going to copy those down, including them in our formula here. So f of t here is going to be e to the 2t times cosine of square root of 6t. My second term here is 5 over s minus 2 squared plus 6. In number 9, we want b as our numerator, not 5. Okay, so we're just going to do to pull the 5 out front, divide by square root of 6, as well as multiply by square root of 6. And so that's going to give us e to the 2t sine of square root of 6t. Ooh, and we're all done.